Which object sent into space has traveled the farthest? This object is already absurdly far away. It carries a nuclear power plant and a message for extraterrestrials. And I'm being serious, really serious. It's like a gold-plated time capsule to be opened by ETs millions or even billions of years from now. So today we're going to learn about the Voyager probes, which are robots that humans are sending out of the solar system, and that tell a bit of our story. To start then, let's go back to the mid-1970s. The United States had already sent men to the moon 6 times, and the Apollo program, which made those trips, had already been canceled. So, space exploration was happening in 2 ways. One part kept using people, kept using astronauts and cosmonauts, and the goal was no longer to reach the moon, but to have space stations. The Soviet Union launched Salya in 1971, and the United States launched Skylab in 1973. The problem with these stations is that they're really cool for doing experiments. They're like hotels mixed with a laboratory that keeps orbiting the Earth. But it's really close to Earth, right? Only between 200 and 500 kilometers high. Space exploration, going farther, reaching other planets, reaching comets, moons of other planets, had to be done without people. We needed to send spacecraft or robots that could take pictures, analyze what the magnetic field is like in those places, analyze the radio waves with machines that would send that information back to us. The name of this type of machine, of robot, is probe, and it's very similar to the satellites we have today orbiting the Earth. It's a cool way to explore distant things since there's no food issues or danger of anyone dying, and so on. At that time, several probes had already been launched. We had already explored the closest planets, from Mercury to Saturn. There were already probes that had passed by, taken a close-up picture. In 1977, a rare planetary alignment was about to occur in the solar system, something that happens only every 175 years. What is a planetary alignment? The planets are orbiting the sun, each at a different speed. So one is on the other side of the sun, another is over here. They're all spread out. But sometimes it can happen that these planets end up close to each other. And what was going to happen at that time was that we would have Jupiter, Saturn, Uranus, and Neptune aligned in such a way that it was possible to send a spacecraft and explore all 4 planets at the same time, taking advantage of the gravity of these planets and their orbital movement, the movement they make around the sun, to propel the spacecraft itself and hop from planet to planet. I know it sounds like a crazy idea, but that's exactly it. You take advantage of the planet's momentum as it's orbiting the sun, it gains speed and moves on to the next one. This thing is called a gravitational slingshot. One very interesting thing for us to understand is that these probes, they're not rockets. The rocket launches the probe into space, but after that, there's no rocket left. They keep moving with their momentum since space has no air resistance, so motion continues. There are some small jets there to control the position, to correct the course, and all that. But it's a very small thing. It has nothing to do with the rocket we have down here. It's important to use a planet's translational movement to gain speed. And that's where the probes come in, which are the stars of our video today. They decided to build 2 machines that would take advantage of this planetary alignment and follow a slightly different trajectory. She's right here by my side all the time. Look, it's this little thing here, the Voyager probe. Both of them are practically identical, okay? So, let's take a look at its anatomy. This main white part, which looks like a satellite dish, is actually an antenna for the probe to communicate with Earth. Holding it now, it seems small, but in reality, it was 3.7 meters wide, almost big enough for a car. These 2 little horns back here were also antennas, but they were used to pick up the frequency of other planets. This rod was for the sensors, so there's an ultraviolet sensor, a particle sensor, and at the tip, of course, we had a camera. The giant rod that looks like, I don't know, that stick tower we made was a magnetometer, a magnetic field sensor to measure the magnetic field of other planets. In the spacecraft's body, we had all the electronics, including a magnetic tape recorder. Because the photos couldn't always be sent to Earth immediately, some were stored here for later transmission. And finally, we had here the 2 coolest parts. On this rod, there were 3 little atomic generators that use plutonium to generate electricity. The plutonium heats up, and they were able to use that to generate energy. And that's why this probe doesn't have solar panels. It only uses that. And the coolest thing of all is this little golden disc right here in the front, which I'll talk about a bit later, okay? But let's follow the journey of these little machines. They were launched in the second half of 1977. Oddly, Voyager 2 launched before Voyager 1. I never really understood why, but that's fine. Right away, they took a unique, beautiful photo of Earth with its little child, the moon. Look how cool that is. It was our first time seeing the Earth and moon like that, but the journey would be much longer. Just so you have an idea, Voyager 1 reached Jupiter a year and a half later. That's when it got really interesting. They started sending pictures of things we'd never seen or understood before. First, the probes managed to spot active volcanoes on Io, which is one of Jupiter's moons. It was our first time witnessing volcanic activity beyond Earth. We were able to see Jupiter's Great Red Spot up close and in detail for the first time. It's a huge storm about the size of planet Earth that spins counterclockwise. Man, there are a ton of discoveries from these missions, but I'm not going to describe each one. Otherwise, this video will go on forever. But just so you have an idea, in 1989, 12 years after launch, Voyager 2 managed to reach Neptune. Along the way, we got close to Uranus and Neptune for the first time. And the probes managed to discover 22 new moons of these 4 planets along the way. And then, that's about when the initial Voyager mission ended, which was to take advantage of the alignment to visit these 4 outer planets of the solar system. The 4 planets after Mars. But what do you think was on the golden record? We made a replica of the record sent with Voyager. It's a disc 30 centimeters in diameter. It's made of copper and is gold-plated. The gold is on top here to protect the information that's here for millions and millions of years. The disc was designed as a time capsule containing a message for extraterrestrials. Because the Voyagers, they could fly very far. And if one day some extraterrestrial found it, they could have information about how planet Earth works, about the great things that human beings invented. They might learn about our civilization much later. And then, as you can imagine, that's a very difficult task, because what are you going to put on a record? Not much information fits here. You can't just say, hey, alien, how's the sky today? So, what did they do? They formed a committee. And the leader of this group was none other than Carl Sagan, who's a superstar astronomer. He's considered the Pope of science communication and passed away some time ago. But he was the one who brought several people together to think about what could represent humanity to an extraterrestrial. They put together a cool collection of images and sounds. Check out what's inside. Greetings in 55 languages, including Portuguese. Check it out.
Peace and happiness to everyone.
In English, it was Carl Sagan's child who did it. There are also several everyday sounds of humans here, and sounds from planet Earth, like a mother kissing her baby or the sound of a whale. One thing I can't play here, because it would cause copyright issues on YouTube, is the music. There was Beethoven, Mozart, and Chuck Berry. They tried to represent as much music as possible throughout the centuries, and also from around the world. There's music from many countries, but none from Brazil. That upset me, since Brazil is important in music. Just so you have an idea, The Girl from Ipanema is one of the most covered songs in the history of music. The Girl from Ipanema is always on lists of the most covered songs. Nothing ended up on the record. Shame on you, Carl Sagan. That wasn't cool. The image collection contains 116 photos or illustrations of things from Earth. There's a lot of science stuff, which is to explain a bit about how this information is being transmitted, to explain a bit about how scientific thinking works here on Earth, and so on. Much of it also reflects our daily lives. They chose images for their representation, not just their beauty, right? Because they explain well what happens here. They were also careful not to include scenes of hunger, war, or bad things. Because it could give a somewhat aggressive impression to the extraterrestrials, right? That it was more of a message of threat than of friendship. And by now, you must be thinking, right? But how will the extraterrestrial read this record? They don't even have a record player. And then you put the image on an audio record. Yeah, Carl Sagan had that same question actually. So, first thing, yes, this record is very similar to black music records. It's almost the same technology. And it came with a needle and a cartridge, right? That's the little tip of the record player, the arm of the record player that can read the record. And, of course, they also sent an instruction manual, which is the cover of the record. That's what was facing outward on the spacecraft. And this is it. They tried to represent everything in the simplest way possible so it could be read by another being, right? By another civilization, in another time, and so on. Anyway, this is the ultimate effort at simplicity here. So, here is the record with the turntable and the stylus. You can understand what rotation the record needs to play at, and how to place the stylus. This is the same view, but in horizontal. Up here, we have the sound waves that will be generated, and how this can be transformed into an image. Down here, there's an image with a vertical scan. It's very similar to the way images were formed on old tube televisions. So, if everything goes well, if they use the needle correctly and manage to decode the images, the first thing they'll see here is a drawn circumference. In the corner is a depiction of a hydrogen atom, the universe's most common atom. Because based on a phenomenon that happens in a hydrogen atom, we can calculate distance and time. This distance and time are used in all this communication. For extraterrestrial to solve this, they'll need some quantum physics knowledge. Still, the message targets an advanced civilization. And finally, in this kind of explosion here in the corner, we have our address in the universe. Where is the solar system located? Here is the position of the solar system in relation to 14 pulsars, which are stars that blink, that pulse. And they serve more or less like navigation beacons in the universe. So if these ETs know these pulsars, they can see the distance from the solar system to each one and figure out where we live. But, Irene, this whole story about everything they put in is really cool. But those spacecraft only reached Neptune, which we know doesn't have intelligent life. It's a waste of time, right? Calm down. I said I went to Neptune in 1989. That was before you were born, right? I was born in 2014, me too, kind of. So, but going back to the probes, after they passed by Neptune, they got a new mission, an interstellar mission. In other words, from then on, they were going to be sent out of the solar system, and that's what happened. They each went a different way. And in 1998, Voyager 1 became the object that humans sent the farthest away, because it surpassed in distance another probe, which is kind of like its older cousin, Pioneer 10, which had also traveled very far. It also had a much simpler time capsule than this one. In 2012, Voyager 1 crossed another boundary, which is the heliosphere. It's a kind of protective bubble here in the solar system, where the solar winds, they dominate. Solar winds are particles constantly released by the sun that travel through space. We call it wind since it's similar to wind. Outside the heliosphere, you'll have more particles coming from other stars in the universe in general. If you check news from then or now, many claim it left the solar system, but that's not exactly true. To really leave the solar system, the probes would have to go beyond the Oort cloud, which is a region after the end of the heliosphere, filled with lots of little rocks and ice. And they're there because they're attracted by the sun's gravity. So that means they're still under the sun's influence. They're still part of the solar system. Just so you have an idea of where they are today, they've already gone way past the planets, okay? They're really far away. Voyager 2 is 140 astronomical units away. Each unit equals the distance from Earth to the sun. So it's 140 times farther from Earth than the sun is, which is about 21 billion kilometers from the sun. Voyager 1 is at 167 astronomical units, which is 25 billion kilometers from the sun. Just so you have an idea, Pluto, for example, is about 40 astronomical units from the sun. So that means Voyager 1 is already more than 4 times the distance of Pluto. Or, if we think in terms of the speed of light, it's about 1 light day away. In other words, light would take a day to travel from the sun to it. It's really far, but at the same time, they're still in our backyard. To reach the Oort cloud, which is that region I mentioned that has lots of rocks and ice and is still part of the solar system, they'll still take 300 years. To leave the Oort cloud, to cross the entire Oort cloud, it'll take between 10 and 30,000 years. Only then will they actually leave the solar system. And the prediction is that they'll be able to pass close to the first star of their lives, other than the sun, in about 40,000 years. Then you might think, wow, 40,000 years, we won't be here then. In fact, we definitely won't be here. This machine will stop working soon as its energy is running out and will only last a few more years. And several instruments have already been turned off along the way. So, these probes are dying, stopping transmissions, and communication is failing. In a few years, they'll basically be dead spacecraft drifting through space. But that's where maybe the coolest part of this video comes in. They're carrying a time capsule meant to last millions or even billions of years. And that information will stay there. Even if the spacecraft no longer works electronically, this record of what the world was like in 1977 is stored right here. Imagine if an extraterrestrial at the nearest star finds this disk 40,000 years from now and opens it. And maybe humanity simply won't exist anymore. Or it won't exist the way we know it. Or maybe there won't even be any record that 40,000 years earlier a probe was sent into space. That extraterrestrial will see things that are much farther away than us trying to understand, for example, ancient Egypt or ancient Greece. I'm talking about a nearby star, but this capsule might be opened a billion years from now. Then, the chance of any human trace is minimal. Maybe the only trace of humanity that exists will be the disk that's here. And all of this is really cool for us to think about our smallness, about how we're almost nothing compared to the universe. It's also really cool for us to think about what would happen if tomorrow, suddenly, we discovered that a dead little spaceship was arriving with a message for us that was left a billion years ago by an intelligent civilization that once existed and that we're sure doesn't exist anymore. If we think about it mathematically, really do the math, the chances of someone finding this record are very, very small. So, in the end, an object like this might actually be much more important to us, because it's a time capsule of what the world was like in 1977. And time capsules are really cool, because when we look back, we also start to look forward and imagine. If we could freeze time right now, would it be better or worse in 30, 50, 100, or even millions of years from now? What are we doing right now, at this moment, to actually make it better? I'll leave it here as a suggestion at the end, our own time capsule. We just made one now when Manuel du Mundo turned 15, and the idea is to open it 15 years later. Now that we're 17, we have 13 years until we open this capsule, stored in the Butantan Institute Library.